In part 2 of our lesson on polar equations and graphs, you will learn how to test for symmetries in polar equations. Very similar to the way that you tested for symmetries in rectangular coordinates in your college algebra class, you will do a replacement in the function equation. If after the specified replacement you get an equation equal to the original equation, then the graph has that particular symmetry. So let's see how this works. First, we will consider the polar axis symmetry test. Now, as I've given you a hint here, polar axis is right here. In the rectangular coordinate system, we call that the x-axis. But in the polar coordinate system, we call this the polar axis. And the test that we do is that we replace theta with negative theta in the equation, and then we simplify it to see if we get back to the original equation or not. So in this example, we have r is equal to 8 minus 5 cosine theta. We are going to replace theta with negative theta. So the equation becomes r is equal to 8 minus 5 cosine of negative theta. Now we have an identity that says that the cosine of negative theta is equal to the cosine of theta. So we can substitute that into our equation, and it becomes r is equal to 8 minus 5 cosine theta. So we can see that the equation we ended up with after simplifying is exactly the same as the original equation, so therefore it has polar axis symmetry. So what that means is, say we had a point over here on the graph, and maybe it is right here. And it would be at some angle, which is theta. So what that tells us is this would fold over the polar axis, and it would line up right here, and we would have the equivalent point at negative theta. So theta and negative theta, these two would line right up on each other if we folded it over the polar axis. Next up, we have the theta equals pi over 2 symmetry test. And theta equals pi over 2, we know in rectangular coordinates we call the y-axis. So the theta equals pi over 2 axis is the vertical axis, and the test is that we will replace theta with pi minus theta in the equation. In this example, we have r is equal to 2 plus 7 sine of theta. So this will become r equals 2 plus 7 times the sine of pi minus theta, because we do that replacement where instead of theta, we put pi minus theta. Now to simplify this, we will want to use the difference identity for sine. So let's remind ourselves that the sine of a minus b is equal to sine of a cosine of b minus cosine of a sine b. And let's get this into our equation here. So this becomes r is equal to 2 plus 7 times the quantity sine of pi cosine theta minus cosine of pi times the sine of theta. We know that the sine of pi is equal to 0 and the cosine of pi is -1. So this becomes r is equal to 2 plus 7 times the quantity 0 plus sine theta, which simplifies to be r is equal to 2 plus 7 times the sine of theta, which is exactly what we started with. So since it's the same as the original, therefore it has theta equals pi over 2 symmetry. So what that means is, say we had this point at an angle of theta. This point would fold over the vertical axis, the theta equals pi over 2 axis, and it would show up over here in quadrant 2. And you can see the reference angle would be theta. So from here to here would be theta, but the angle itself, starting from here going to here, that angle is pi minus theta. So that's why the test is replace theta with pi minus theta. The third type is the pole symmetry test, and the pole refers to this point right here where the two axes intersect. In the rectangular coordinate system, we call that point the origin. So the pole symmetry test you can think of in rectangular coordinates as being the origin symmetry test. But in the polar coordinate system, we will replace theta with pi plus theta in the equation. So in this example, we are given that r is equal to 5 cosine of 4 theta. So let's do this substitution where we replace theta with pi plus theta. The equation becomes r is equal to 5 cosine of 4 times pi plus theta. So this becomes r is equal to 5 cosine of the quantity 4 pi plus 4 theta. And we have an identity for the cosine of a sum. We know that the cosine of a plus b is equal to cosine a cosine b minus sine of a sine of b. Our equation becomes r is equal to 5 times the quantity cosine 4 pi cosine 4 theta minus sine of 4 pi sine of 4 theta we know that 4 pi is coterminal with 0, so the cosine of 4 pi is equal to 1, and the sine of 4 pi is equal to 0. So our equation becomes r is equal to 5 times the quantity cosine of 4 theta minus 0, which is r, is equal to 5 times the cosine of 4 theta, which is exactly like what we started. So because it is the same as the original equation, therefore it has pole symmetry. Now for pole symmetry, you can think of it much like you did with origin symmetry in the rectangular coordinate system. So if we start with this point here at an angle of theta, think of folding it over the horizontal axis first and then folding it over the vertical axis. And it ends up over here. So I want to make sure you understand that pole symmetry means the point travels an equal distance through the pole. So from its starting point, it travels directly through the pole and goes an equal distance, and in this case, ending up in the third quadrant. Pretty easy to see that this reference angle right here is theta, which means if you started from the positive x-axis and went all the way over, you can see that is going to be an angle of pi plus theta. And that's why the symmetry test has you replace theta with pi plus theta. Because if the function lines back up with itself, in other words, the equation you get in the end matches the equation you started with, then that means the graph will have pole symmetry. In this example, we have to determine the symmetries of r equals 2 plus 3 sine of theta. So we will need to do all three symmetry tests. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. To test for polar axis symmetry, we know that we will replace theta with negative theta. So our equation becomes r is equal to 2 plus 3 times the sine of negative theta. We have an identity that says that the sine of negative theta is equal to negative sine theta. So let's substitute that in our equation, and it becomes r is equal to 2 plus 3 times negative sine of theta, and this simplifies to r equals 2 minus 3 times the sine of theta. Now this does not match the original equation, so we have to say no on this one. No polar axis symmetry exists for this equation. Next, we will test for theta equals pi over 2 axis symmetry by replacing theta with pi minus theta in the original equation. So we get r is equal to 2 plus 3 times the sine of pi minus theta. We know that we will use the difference identity for sine, which is sine of a minus b is equal to sine a cosine b minus cosine a sine b. Our equation then becomes r equals 2 plus 3 times the quantity sine of pi cosine of theta minus cosine of pi times the sine of theta. We know that the sine of pi is equal to 0. The cosine of pi is equal to -1. So our equation becomes r equals 2 plus 3 times the quantity 0 plus sine theta, which simplifies to be r is equal to 2 plus 3 sine of theta. And this matches the original equation. So therefore, it has theta equals pi over 2 symmetry. The third test is for pole symmetry, where we replace theta with pi plus theta. So our equation would be r is equal to 2 plus 3 times the sine of pi plus theta. We will use the sum identity for sine, which says that the sine of a plus b is equal to sine a cosine b plus cosine a sine of b. Then our equation becomes r is equal to 2 plus 3 times the quantity sine of pi cosine theta plus cosine of pi sine of theta. Substituting in the trig values that we know, sine of pi is 0, cosine of pi is -1. This equation becomes r equals 2 plus 3 times the quantity 0 minus sine theta. Simplifying, we get r is equal to 2 minus 3 sine theta, and this does not match. The original equation. So we have to say no. So it turns out that r is equal to 2 plus 3 sine of theta only had one type of symmetry, and that was theta equals pi over 2 symmetry.